Hi everybody, welcome to my project focusing on IHO S-100 main feature. Specifically, we are going to analyze resolution S-412 weather overlay and S-111 surface currents. I'm really glad to introduce Mr. Ezio Barotti and Mr. Emiliano Caroletti, fleet nautical instructors, that are here for giving us an opinion having detailed focus on the upcoming S-100 standards in all the aspects regarding cruise shipping activities and management. As expert on marine shipping, indeed working on professional educational field, they are strongly affected by those changes regarding new standards on electronic cartography, which are going to be effective on board starting from 1st January 2024 as per IHO roadmap. Before giving the word to them, I would like to present the scenario on which together we are going to build a discussion. We're supposed to be on a cruise ship with the following characteristic: length overall 220.6 meters, maximum breadth 34 meters, air draft 47.5 meters, maximum draft 7.8 meters, displacement 30,577 tons, gross tonnage about 57,000. About steering and propulsion, we have 4 main engines, total power 21,180 kilowatts, 2 variable pitch propellers with maximum speed of 20 knots, we have 2 rudders with maximum opening angle of 35 degrees, 3 bow thrusters of 1,200 kilowatts each and 1 sun thruster of 1,200 kilowatts. We decide to plan a voyage from Tokyo in Japan to Busan in South Korea, passing from Common Strait for obvious saving-mile passage planning and crossing Japan Sea once exiting from the strait to reach Busan as final destination. The weather has been checked as per procedure regarding VPP meeting before departure. However, since it's August, the team is fully aware of tropical cyclone season, commonly affecting the itinerary during this period. VP officer and master agree in a route as per the following schedule: Tokyo Common Strait, full away on passage 2100 on 8 August, pilot on board 1400 on 10th, distance 570 nautical miles, speed required 40 knots. Common in, common out, pilot on board 1400 on 10 August, pilot off on the same day 2130, distance inside the strait 90 nautical miles, speed limit inside 12 knots. Common out, Busan final destination, pilot off 2130 on 10 August, standby engine 6 o'clock in the morning on the day after, distance 110 nautical miles, speed required 30 knots. Here we have the voyage overview on which ship is leaving from Tokyo bound to Busan, passing from the Common Strait. On this image, indeed, a weather overview has been defined as follows. We will discuss deeply the weather forecast scenario directly during the interview. Thanks for your attention and I hope you will enjoy the video. Welcome to the final interview, and I'm really proud to present our expert joining my university project. Thank you.
I am Emiliano Caroletti, Senior Nautical Instructor at S-100, the training center for Carnival Corporation. I spent my career at sea on passenger ships, and then I went to S-100 to start a career as an instructor.
Hi everyone, my name is Ezio Barotti. I'm a specialist nautical instructor at S-100, that is the training center of Carnival Corporation. I sailed for many years on cargo ships and then passenger ship. At a point I moved to the training side of the business, and I'm happy to support Raffaele with his project. Thank you for having me.
We have seen the ship planning and the analysis of weather condition before departure. On that basis, we also spot a developing vortex southwesterly of Japan Sea, which could represent matter of attention for the ship in terms of safe navigation. It's really evident that at the time of consulting weather forecast sources, those could be referred to a quite old update, since the broadcasting period is usually every 6 hours. Emiliano, which are the current sources on which the bridge team on planning and on monitoring phase are using to determine weather data?
Thank you, Raffaele. If we look at the IMO voyage planning guidelines, there are documents and information that we need to gather during the appraisal of the voyage. And usually this appraisal starts quite early or months before starting the voyage. And those information are about current and tidal atlases and tide tables, climatological, hydrographical and oceanographic data, as well as other appropriate meteorological information. And also we need to look at the weather routing publication. So today the captain relies heavily on weather forecasts to plan the voyage. And the weather information is vital for the safety of the people, ship, cargo and the protection of the marine environment. Normally the broadcast, as you mentioned, of weather data happens every 6 hours, but delay due to poor communication are not so rare. This information must be considered while planning and executing the voyage. Now, what we really have now available, usually if the plan has been created months in advance and the only information available are the historical data, they are giving us information about the past. With this information we can try to predict what will be the weather in the future. Unfortunately, those information as historical, and if we are planning the voyage well in advance, they are not giving you enough information, and the behavior of the captain and the bridge team will be really reactive to the changes in weather condition. So if we look at the scenario, the captain needs to study, collect historical information, and with that in mind, he will start to plan the voyage. Of course, the captain needs to have a main plan, but also contingencies to avoid to meet the vortex in the middle of the strait. Then, once the plan has been created, we go in the execution and monitoring stage. And now, during the execution and monitoring stage, while the ship is sailing, the captain has a lot of tools available. As we know, the captain can look at the Navtex, receiving a bulletin and weather forecast. Nowadays, what is happening right now, it's really the captain is collecting information from different sources, and then he needs to understand, interpret, and evaluate the impact of this information on the voyage. So you can understand that it's quite difficult because you need to look, you need to read the chart, you need to understand Navtex information, chart information, and then you need to put them in a context of what the ship is doing. So you need to combine the navigation information with the weather information.
Thanks, Emiliano, for your answer. Now I would like to ask you, what do you think about in how bridge team, VP officer, and master could act accordingly? Do you think that the scenario specifically can lead to a dangerous situation for the ship, or the team will be able to promptly spot any further and dangerous changes?
Of course, the scenario that you just described can lead to a dangerous situation, because we can imagine that the ship is approaching the strait and there are a lot of current in that strait, and then we have this low pressure. So of course the captain and the bridge team, they need to discuss, they need to understand, analyze the information collected during the appraisal. Then while they are monitoring, they really need to monitor what the ship is doing, what the low pressure is doing, and they need to understand what will be the situation while transiting the strait. And as you see, there is not a continuous stream of information, but they will receive information about weather every 6 hours, and the forecast will be 12 or 24 hours. So there is always a gap, and while the ship is proceeding and approaching towards the strait. So there is a delay. There are gaps in the information, so the captain needs to plan to develop a strategy with, in certain circumstances, not enough information. And this, as you can imagine, can impact the safety of the navigation.
Okay, Emiliano, so today, are there other similar softwares or tools comparable to S-412 future implementation?
Raffaele, yes, of course, on the market there are a lot of services, a lot of providers. It's a free market, as you can imagine, and there are a lot of companies providing weather information, weather routing, so you can just pick one. So what happens usually, the raw data are provided by NOAA, for example, so you can buy the data from them, and then you can create your software using the data from NOAA, and then you will sell this service to companies around the world, ship companies. My concern about these services is about reliability of the information, from where they buy the data, and also dependability to internet connection. So you can imagine on board of a ship, you are in the middle of the Pacific or the Atlantic, and then you have a problem to your satellite antenna, you lose communication, so you lose the weather information. So this is what we stand right now. The other important aspect about these services on the market is the fact that you need to subscribe. And those companies are providing you different services. So weather forecast for 6 days, 9 days, 14 days. More you pay, more you get. And also they provide routing information. So you decide departure port, arrival port, and the system, the software that you buy will provide you a weather route. This is what we have right now. Plus, there are a lot of ECDIS manufacturers that are now incorporating weather layer on their product. So you buy the ECDIS from the manufacturer, and they will also sell this kind of service. Of course, then you can understand that on the market there are several manufacturers. Everybody is trying to sell their product. There is a lot of fragmentation, and there is not a standard approach to this. So every single manufacturer is trying to sell his product to differentiate the product from the other, from the competitors. So every single ECDIS looks like a bit different. And this is for the seafarer, it's not really good, because you jump from one ship to another and maybe you will find a different system. So you need to adapt yourself. You need to understand how to use it. You need to understand also the limitation of this approach. Plus, don't forget about shoreside. Now, a lot of companies, they establish this fleet operating center ashore, and the main purpose of the fleet operating center is to support the fleet. So they also need to buy weather information, they need also to be able to display weather information, and they need to be able also to integrate weather information with the fleet information, because the main purpose of the fleet operating center is to support the ship, especially in bad weather situation. So everybody is trying to find their way, but bottom line, there is no standardization.
Really clear answer, Emiliano. So, thanks to S-412, which are now the benefits on daily basis operation that the team will acquire?
So, in my opinion, the main benefit of the introduction of the new standard are standardization in data format. So finally, the International Hydrographic Organization, they will design and define the standard of file exchange and file format, data format. So everybody, they will be able to download, load, upload their information that will be readily available to everybody. Then we will also standardization in visualization. So doesn't matter which system is running, which ECDIS you have on board, the information that will be always looks like the same, like we have now with the ENC, with the electronic navigational chart. Doesn't matter the manufacturer, they always looks the same. Then we will have also reliability, because finally everything will be in the hands of the hydrographic offices, and for them the main purpose, the main goal of an hydrographic office is the safety of navigation and not anymore making money. Plus will be consistency among hydrographic offices, because they need now follow a standard. For the end user, people on board of a ship, they will have weather information as an overlay on their ECDIS. So finally we'll be able to see the navigational information, sensor input, the position of the ship, then we will see also the weather information together as a layer on top of it. And we can really see the development of the weather situation and the navigation. So this will really help the seafarers while they are executing and monitoring the voyage.
Okay, Emiliano, just a last question. As fleet senior instructor, do you think that generally seafarers will be really helped by S-100 and by S-412? How they will be able to extract and consult data for a better planning and monitoring?
Raffaele, these are two difficult questions. I will try to answer. I believe that the S-100 will introduce new standards, so finally we'll be able to really standardize everything across the industry, so one standard for the weather information in this particular case. So for me, the S-100 have a lot of potential. Of course, now at this stage of development, it's difficult to foresee what will be the final product. What I saw now looking around is some prototypes. Still we have a draft standard, so they are still working and discussing. But from the point of view of an instructor, I strongly believe that the mariners need to be trained on the use of the new tools before the full implementation on board of a ship. You can understand that having a new tool without the necessary knowledge on how to use it can be dangerous. So really, as an instructor again, I believe that soon somebody needs to start the discussion on training the seafarers in the use of the new tools. And also would be nice to see seafarers also involved in the development of the new tools.
At this stage, the voyage planning previously defined includes a tough passage in the common strait. The ship and the bridge team must plan the passage with a specific time window, since the current intensity in the strait can reach a maximum of 6 knots in ebbing or flooding, impeding safe passage. Mr. Ezio, which risks are involved during the navigation in a narrow channel like common strait?
Raffaele, thank you for the question. It's a really good one. There are many factors that affect navigation in narrow waterways. I will usually categorize them in geometric factors such the width of a channel, depth of the channel, if there is any constraint due to buoys channel, etc. Traffic is another concern that we have to keep in mind. Meteorological and oceanological issues such, of course, wind, current, and so forth. Ship design, equipment faults, and human-related factor. So therefore, in my opinion, sailing in such areas is a delicate operation where the major risks are grounding and collision due to the mentioned events. As you can recall, possibly in recent years, we have some incident where meteorological conditions play a key role in accident that lead to the blockage of places. For instance, Suez Canal, if you remember, was a great disruption for the shipping industry worldwide. So these adverse consequences can also lead to have not only problem for the international shipping, but also create pollution, damages, fire, injuries, and therefore endanger human life. To reduce the likelihood of an incident, I believe that assessment and risk mitigation have to be considered of paramount importance. One way of mitigating the risk is voyage passage planning.
Okay, Ezio, thanks for your answer. Now, focusing on weather condition and currents, which are the data and sources that with the current instruments the bridge team is able to predict in advance, and which are not?
Raffaele, thank you for this question. It's a very interesting topic. I would like to expand a bit on it. So I will start for the sources available. As you know, as a mariner as you are, we have different sources on the bridge. I will start with the sailing directions that, as we know, are providing some kind of insight. But usually we rely on local resources such vessel traffic services, as you know, pilots, local weather services. We have a local port agencies and experiences. So these are mainly the sources that we use. As you know, with internet on board, I think nowadays even the smallest vessel have this opportunity. So they have internet, therefore they can use weather services online. What is predictable, in my view, are more or less with a certain approximation, the wind that you will encounter, the current, tides, and therefore consequentially, you can predict the underkeel clearance and if there will be any squat effect or bank effect. Non-predictable, as you can imagine, will be extreme weather events and conditions such heavy downpours, floods, tornadoes, and hurricanes. Or better, not predictable. They will be predictable with a certain approximation when we are getting closer to the approach in an area where we navigate in, but when we are planning, possibly from a practical point of view, we will not have an insight on that. Therefore, I would like to say that they are predictable closer to the event, but possibly non-predictable while you are planning your trip. And I hope this satisfies your curiosity on this matter.
Yes, Ezio, you did completely. Now, having read S-111 surface current product specification, which are the main features introduced and which changes are the most evident for an operational usage?
Raffaele, a very interesting question and topic as well. With introduction of S-111, there are a few features that I would like to mention. I will start with an idea that is the backbone of this standard, that is the advent of electronic navigation. Since the introduction of ECDIS and integrated navigation with a focus of ENC and therefore digitalization of the products, I think that the surface current data and updates are more accessible and therefore they are more easier to be integrated into navigation display. The main features will be, of course, that this integration of the chart with other supplemental data improve decision making and result in a more efficient navigation. When we go to the main changes, I would like to reflect on the current status in the industry. So as we speak, mariners relies on, as you know, on our copies and calculation on weather services and local station. For instance, when you are in the US, we have the NOAA Tides and Current Service that is free of charge that can be consulted freely on internet and give you exactly an insight about the current condition in ports, for instance, like Miami, but they are all around US coasts. Unfortunately, this approach has these limits. Why has these limits? Because you still have to sort of say decouple the navigation from the investigation phase of where you're gathering your data. With the introduction of the standards such the S-111, data are readily accessible and therefore since they are displayed in a very understandable way, as we can see in our presentation, using arrows that are easy to understand for every mariner that is using it. These will shorten reaction times from breach team and will give an opportunity to understand immediately what's happening. Situational awareness will improve sensibly due to the clearly displayed value. I would like also to add a very important topic that as mariner is always on the back of our mind. So current has a strong effect on the navigation of our vessel. We have to remember that just 1 knot more of current have a tremendous impact on the maneuverability of our vessel. Therefore, having this data readily available and display in an easy way on our screens will for sure enhance safety.
So we talk about specific application of S-100 generally, and in the details, all the feature of S-412 and S-111. Now, with Mr. Ezio, we are going also to understand which other topics of S-100 will deeply affect and which changes it makes. So, in your opinion, does S-100 turns mindset from huge and detailed planning to a more real-time navigation?
Well, Raffaele, it's my belief that even with the latest technological improvement, a well-sound planification of the voyage is still a key element to enhance safety and is the foundation in optimal voyage. Now, say that, I recognize that nowadays mariners are dealing with a meteorological event with a certain degrees of uncertainties, mainly due to the non-up-to-date information. What I mean with that means that now we are receiving meteorological information and oceanographic information under certain degrees of delay. Sometimes even up to 6 hours. It's my opinion that having real-time data, of course, support proactivities and increase the team situational awareness. So this will enable us to be on top of the situation rather than react. So this will enable ships to adapt to a developing scenario and possibly prepare a contingency plan in due time. I'm referring to alternative routes, speed management in order to reach a point in appropriate time. We discussed briefly this morning about common strait and 6 knots of current. So with real data, you can really be proactive and understand what will be the most sensible things to do in terms of approaching the strait. So I think to summarize that, is an improvement, is absolutely changing the way how we'll navigate our vessel in the future. But I will always remember to everyone and to people that I encounter that the foundation of the sound voyage and safe is always having a good voyage passage planning. Well done and well prepared.
Really thanks, Ezio, for your answer. And we are aware that the actual methods for consulting data are taking as input many sources coming from different providers, as we said. So has S-100 imposed a general standard on data acquisition or not?
Well, Raffaele, honestly, data standardization in our business is a necessity, and is there in place to guide the software and hardware manufacturing in the development of integrated navigational systems that complies, of course, with international rules and regulation. Given this requirement, I believe that the International Hydrographic Organization surely indicates a standardized way to approach data acquisition. And I think it's a good thing because besides the well-known GMADSS meteorological service or the latest introduced Iridium safety cast, every mariner relies a bit on his gut feeling on what provided by the company in the data acquisition process. Mainly, if your company provide you and pay for a service, you will likely incline to use that service because it's what is provided by your company. Or if you find yourself comfortable with Windy, you will use Windy. I think, as a bottom line, that a standardized approach will be beneficial in the long terms of data interpretation and usage by mariner. Why? Because standardization enable training center, for instance, to prepare a good package, a good training package in order to train our mariners in do what? In getting and understanding the information that are displayed on ECDIS, for instance. We know from the past that the ECDIS courses are in place as per SCCW, and they follow a center standard. So I will not be surprised if in the future we will have also a course that is mandatory related to the interpretation of the data. So to conclude my statement, I think that standardization is a positive thing. It will help the mariner in the tuition and understanding of these data, but also will give opportunity to prepare a package in order to train properly a seafarer of the future. Thank you, Raffaele.
Okay, Ezio, in some ways, has S-100 reduced user personal interpretation of data that in the past caused wrong analysis resulting in low situational awareness and poor quality planning? Thank you.
Well, Raffaele, even in this case, I see the benefit of a standardized approach. Using information that are constantly conveyed give the opportunity to every team member to correctly understand and interpret the information provided by the system itself. Consequently, the whole bridge team is on the same page. That for bridge resource management standpoint of view is increasing situational awareness. It is entitled the bridge team member to intervene in a timely and effective way in case of data misinterpretation. For instance, if the person that is in the con and is navigating the vessel misinterpreted the data, if we have a standard approach and it's clear to everyone what the symbol display on your ECDIS means that even other bridge team member could intervene and correct the assumption of a navigator. This is just, to me, a very important factor when we are talking about the teams on the bridge and how they communicate among themselves and how they navigate the vessel. An extra benefit of a standardized approach still there, and is that in this way, even newly on the job, for instance, cadet officers, or an officer that is just newly hired and is not aware of all the bits and pieces of a bridge, a new hire can help the team to succeed. Why? Because we have a standardized approach, therefore it's clear to everyone what the information on the display means for a safety standpoint of view.
Okay, Ezio, this is more general question, but in your opinion, which aspects of marine shipping are interested and affected by IHO S-100 implementation?
Well, Raffaele, even in this case, I think that the standardized approach shown by the IHO S-100 standard will for sure enhance safety. As we mentioned, everyone will understand what the data means, and they are of easy intuition through the navigation process. So I think really safety will be enhanced. We will have easily accessible, readable data. That is, as you know, is a very important factor also related to safety. This will increase fuel efficiency and consequently will enhance environmental protection that, as you know, nowadays is a very important topic. And there will be for sure a risk mitigation. So I think that in the end, enhanced safety, easily accessible, readable data, full efficiency, enhanced environmental protection, and risk mitigations are the aspect of marine shipping that will be interested by this newly developed standard.
Okay, Ezio, just the last question for you. And I think that it will be important because you will be directly involved, and we have to keep a special care on the final user, so on the seafarers. So, Ezio, my question is, all the functionalities that will follow the introduction of S-100 standards could in some way overload the final user as ship officer, master, or who is consulting the available data?
Well, Raffaele, it's a very competent question. I believe, as I've seen in the past, that there is a high possibility that the users, so the end user, before the mariners, could feel overwhelmed by the high number of information available. Nevertheless, the same happened when the first active machine has been installed on board. I remember at that time we were like, oh, what is this? We always did it in a different way. We always safely navigate the vessel. Yeah, well, I don't think this is the right approach. The right approach will be that through training and understanding of the system that we have at hand, mariners will overcome this sense of uneasy and will be able to fully benefit of improvement made possible by the new standard. So I'm really a believer that the new ways that ships are navigating nowadays are the good way of doing things. That means an integration between the expertise of the mariners on the bridge, but also with an expert and confident use of a new technology. And I think IHO, with these standards, is going towards the right direction.
Okay, really thanks, Emiliano, for your opinion on this important short future technology, we can say, that also shortly everybody of us will be involved in learning or as you in teaching. I'm really glad for having your knowledge in my project. Thank you.
Thank you, Raffaele. It was a pleasure to be part of this project, and good luck with your study.
Okay, Ezio, also many thanks to you. I know you since long time. I know your experience, I know your knowledge, and it's again a big pleasure for having you in my personal project in the university.
Well, Raffaele, thank you for having me. It's been a pleasure to meet you again and to help you out in this project. I wish you all the best for your university and study career and all the best for the future. Really, thank you everyone for having me. Have a good one.